Okay, back at it again! Woo! We're doing 4.7, modeling and solving problems with quadratic functions. So, our mission today is to take them wordy problems, these ones here, and I'm going to show you a progression. So, there's basically four kind of question types we look at, kind of from the less tame to the wild ones at the end. So, four question types. The first one we're going to look at is where they give us the equation. Could be equation, could be the graph, okay? So, this particular one, we're not going to do this, I'm just going to look at it. But it says some engineering students constructed a potato cannon on the roof of a building. The height above the ground, h meters of a potato, t seconds after it's shot from the cannon is modeled by this equation. So that's the height of the potato, and t is the time in seconds. All right, so you figure out a time, plug it in here, it's going to give you the height of the potato at that time. And here's the graph for that particular equation. Okay, so they're on the roof of the building, so they're up here and they're shooting it, and boom, it hits the ground at 4.5 seconds. So if they give you the graph, you can tell stuff like that. This one's not quite obvious. It looks like the vertex is around there. Okay, it's hard to be 100% sure, because this one's pretty flat up at the top. But, you know, if I gave you the graph, you could get the vertex, you could tell me, like, I could say, like, hey, how long was it in the air for? And you could say, well, 4.5 seconds or something like that. Or what was the starting height, like, how high was the roof? Probably not going to give you questions like that. A bit too easy if I give you the graph. So, basically, in this particular question, they're asking for the maximum height of the potato, all right? So that would be the vertex. Right, and instead of xy, it's th, right? So that would be the x value, that would be the y value. And if we're looking for the maximum height, we'd be looking for that. So what I'd like to do is have exactly the same situation, but I'm just going to change the equation. Okay, so if you have exactly the same scenario, what is the maximum height of the potato if the equation that models its path is this one? Okay, this one's just going to be a bit nicer to work with. No decimals, right? So, if they're asking me for the maximum height, then I need to be like, well, that's the vertex. And if I want the vertex, then I want to get it in standard form, because standard form is going to tell me the vertex really easily. So, if I'm going to get it in standard form, I must do some CTS, complete the square, right? So let's go ahead and do that. So I'm going to rewrite h of t. Now if I'm completing the square, I need to make the squared variable, the t squared, positive. So I'm going to go ahead and pull out the -4, and I'm going to get t squared. 24 divided by -4 gives me -6t. Leave yourself some room, because you're going to write your magic number there that makes this a perfect square trinomial. And we're going to leave the positive 10 alone. Okay, that has nothing to do with us making the perfect square trinomial. So I'm just going to take the -4t out, and if you distribute it back in, you get back to where you started. So I know I haven't done anything that I'm not allowed to do. So I'm going to go grab my k value. So I'm going to grab the b value, divide it by 2, square it. Okay, write that intermediate step, so it's -3 squared, and my k value is 9. So I'm going to add 9 in here. Now, I can't just willy-nilly change the trinomial, so I added 9, but be careful, because I didn't just add 9, it's actually -4 times 9, so I actually just subtracted 36 from that by doing that. So I need to make it whole. So I subtracted 36, so to make it whole, I need to add 36 right there. -36 plus 36 is 0, and we're good. So now we can complete the square. So we rewrite the -4. Now I know it's going to be t plus or minus a number squared, and then over here, 10 plus 36 is 46. That's great. Remember, the number you write in here is almost that intermediate step, so I can just pop the -3, and then I'm guaranteed that I now have something that factors beautifully. Okay, now that I have it in this format, I can easily grab the vertex, right? So we know from our transformations unit that on the x-axis, the sine's law was the opposite, so we get 3. So that would be, after 3 seconds, the maximum height is right there, 46. So max height is 46. Don't forget the units. Boom! Done! That's about as easy as it gets. Yeah. Well. On to the next one then, huh? Let's see. Just trying to do a page flip here. All right. What's the next joy we get? Ah, yes, the area problems. These are great. Absolutely stunning. So some problems can be solved by writing and then graphing a quadratic equation. So yeah, a person has 100 meters of fencing to enclose a rectangular garden. What are the dimensions of the largest possible garden? Well, if you have an area question, I definitely say you should sketch a diagram, even if it's like just a crappy square, it will help you out. Then you need to make a statement about letting, like, what are your variables, right? So let the length of the garden be L meters and its width be W meters. So the area is going to be length times width, so that's good. And then use the given information to write an equation for the perimeter, right? If we are going to find, so this is the question, by the way. So we have 100 meters of fencing, right? So you can build this rectangular garden however you like. So you could do, you know, like as long as it adds up to 100, it can't exceed 100, and you have to use exactly 100. So it's got to equal exactly 100. So when I do my perimeter, I get 100. I want to make the largest area possible. Well, it's going to end up being a square probably. We'll see though. So to solve this one, I got to set up my perimeter formula first. Okay, so the perimeter is 2 times the length plus 2 times the width, right? So I know that I have 100 meters of fencing, so I pop that in there, okay? And now I need to solve it for one of the variables. It doesn't matter which one. I arbitrarily chose W, okay? So I move the 2L over here, so I subtract it from both sides. And now I got 2W, so I divide everything by 2. 100 divided by 2 is 50. Negative 2L divided by 2 is just negative L. That is still an L, by the way. It's not a 1. So now I have an expression for the width. And what am I going to do with that? Well, I'm trying to maximize my area. So my area is length times width. I now have an expression for width in terms of the length. So what I can do is I can write that in. So instead of writing W, I'm going to write, well, the width is actually 50 minus L. And once I distribute this into the brackets, I'm going to see that you're going to just get a parabola, right? So you get 50L subtract L squared. Whenever your highest degree is a square, you have yourself a parabola, which means there will be a maximum, right? Now, this particular parabola, because the square term is negative, it's going to be opening down. It's definitely going to be opening down. So it's going to look something like this. And actually, I can tell from here, my x-intercepts are going to be 0 and 50. Right? I get 0 from this one, and when I go 50 minus L equals 0, I get 50. So somewhere over here, I have a maximum, and I need to find it. I would say in this case, because you have the intercepts, right? So I'll do that work over here. There's the first intercept, setting that equal to 0. The other intercept comes from setting that equal to 0, which just gives me, move that over there, you get L equal 50. Right now, can you find the x value, or in this case the L value of the vertex, if you have the 2 x-intercepts? Yes! We were doing that yesterday. It's just right, it's the midpoint, right? So go 0 plus 50 divided by 2, and now we know that the maximum is at the L value 25. Perfect. Well, is that all we need? Yes. We now know the value of L at the max. And we have an expression for the width right here. So we just found out, well, the length needs to be, oops, not 50, 25, right? So the length needs to be 25 meters. We have an expression for width over here. So the width of this garden or whatever is 50 minus L, so 50 minus 25. So the width also has to be 25 meters. So what did we find out? Well, our rectangular garden is actually a square where the length and the width is 25. Does it add up to 100? Yeah. So don't forget to write a little statement. So the length and width of the garden are both 25 meters to maximize area. Maximize the area. Now some of you might be like, "When? A square? That's a square. That's not a rectangle." But actually, a square is a special case of a rectangle. Oh, that's a little sneaky. But now we know squares are efficient, so be square. I'm not getting any less insane being by myself on quarantine all these days. All right. I didn't even know I had all the work there done for you, and we just did the whole question. So we did all that. We did it all. 25, we never found the other part, but we found the length and the width. I bet you it's 25. And the area, what is 25 times 25? I don't know. Oh, it's too big. Wait, I probably have it over here. 625, yes. The area is 625 meters squared when you go 25 times 25. Yes, 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 yes. Wonderbar. So that would be what goes over here. Wonderful. Okay, so we did it. We didn't have to complete the square. I found a better way of doing it, so go away. I found a better way. All right, we're getting into the meat and potatoes. We got 2 more question types. Now, this is one of my favorite kinds. Actually, no, it's not. Sorry, this is the one I don't like at all. They're not hard, I just don't like them. So problems involving numbers. So this is a really weird one. And this I grabbed an example from an old textbook that was really good. So determining max or minimum related to operations with numbers. So they say, hey, you got 2 numbers that have a sum of 20. It's those hypothetical questions that nobody likes to answer. So 2 numbers that have a sum of 20. Does the sum of their squares have a max or a min value? Determine this value and the 2 numbers. If you're going to do one of these questions, it's very similar to the area one where you have to define some variables. You can't skip this step. It would be like leaving your house without your clothes on every morning. Like, you got to define the variables. It's the first step of the day. So 2 numbers have a sum of 20. So I'm going to say, like, let x be the first number. All right. And yeah, do we need it? Yeah. And 2 numbers, right? And let y be the second number. And you must write it out so the reader, me, the guy marking it, knows what you're doing, okay? So please do that, otherwise I would be very upset with you, and we will not be happy. Okay, so 2 numbers have a sum of 20. Great. So set up equations. That's your second step. So read the question again. You might have to read it twice, 3 times. So one equation is that x plus y equals 20. And then it says, does the sum of their squares have a max or a min? The sum, so the sum of their squares. So when I square x, I get x squared. When I square y, I get y squared. Does the sum of their squares have a maximum or minimum value? Well, this is equal to the sum, so we'll just call it s. Okay, so I don't know. But I do know that I have a parabola here, right? Probably. Right now, it's actually a circle. You're going to need to use one of your equations and get rid of one of the variables here. But you need to rewrite it. I can never solve this unless I have the same variable. So what I'm going to do, I'm going to tell you what I'm going to do. I'm going to go to my first equation because it's easy. There's no squares. And I don't know, I'm going to solve it for y. Whichever one you like. Solve it for y, solve it for x. I'm going to solve it for y. So if I solve it for y, subtract x from both sides, and I get that y must be 20 minus x. Does that make sense? Right? Like, if the 2 numbers add up to 20, and I know x, and say x is 6, I could figure out that y would have to be 14. So there we go. Now that you have that little fun bird, you can pop it in there, and now you would have an equation that only has one variable, and you'd be able to solve it using your knowledge of quadratics. So I have x squared plus, plug in what y is, 20 minus x squared, that's equal to the sum. Foil that out. I know, it's going to suck, but we're going to have to do it. So x squared plus 20 times 20, 400, and then you have 20 times negative x, that's going to give you a negative 20x, and then you're going to have negative x times 20, so you get another negative 20x, and then x times x giving you an x squared, that's equal to the sum. Group your like terms, so we have 2x squared minus 40x plus 400 equals the sum. Now, could you find the vertex? It's asking me, does it have a max or a minimum value, and determine the value and the 2 numbers. So, well, let's see. Based on this parabola, you should be able to know a couple things about it. Is it opening up or down? Well, the a term is positive, so this parabola is opening up. I don't know if it has roots or not. It probably does. Okay, so it's going to be something like this, right? It's opening up, and if it's opening up, then it has a minimum value. Okay, Okay, so I answered one question, it has a minimum. So, but now they want to know, well, what are the two numbers? Well, I'm going to have to find the vertex. In order to find the vertex, I have to factor it. I might be able to pull out a 2. Let's just see what happens. I'm just flying by the seat of my pants. Two numbers that multiply to 200 and add to 20. What is it? 1 and 2, 4 and 50. 3 is not going to work. 4 and something. What is it? 4 times 50. I already did that one. I'm gonna look at my notes. Maybe it's too hard to factor. Maybe. But we could complete the square. Let's do that. I'm losing my S. Oh, let's do it. Let's complete the square. So I'm going to basically go back to this step. By the way, why am I doing this? Like, I'm just showing you that, like, when you're doing a question, you're going to have a thought process, right? So, like, you might try to factor it normally. I do want the vertex, so I should have been a bit smarter and been like, if I want the vertex, I should just get it in standard form. That's the easiest way to get the vertex. So, complete the square. So, the sum equals, I'm going to leave the 400 out of it. I need to make the x squared turn positive, so I pull out the 2. And I get this. Leave yourself some room for your magic number, and then it's plus 400. So get your k value, and where can I do that work? Maybe over here. So grab the negative 20, divide by 2, square it. Write the intermediate step, so it's negative 10 squared. So it's 100. So I'm going to add 100 in here. Now remember, I didn't just add 100, I added 200. So I need to subtract, not 400, whoops. I added 200, so maybe I'm going to subtract 200, right? I added 200, need to make it equal to 0, so subtract 200. That's going to be much better. Now I can finish completing the square, so it's going to be 2x minus 10. Remember, it's that intermediate step, that's the numbers right in there. And then here I get 200. So what's my vertex? Well, my vertex is going to be 10, comma, 200. Now, which one of these is the numbers? Well, remember, you defined your variables. That's your x value, right? What's this? Some of you might say, well, that's the y value, but remember, this is the sum, right? So that's the sum. That is the sum, right? This is the sum equation, so this is the x value that generates the minimum sum. So the minimum sum right there. So I go back and I can say, okay, is it a maximum or minimum? It's a minimum. And determine the value. Okay, the value of the minimum was 200, right? That's the y value over here. And then what are the two numbers? Well, my two numbers were x plus y equal 20. I know that x was equal to 10. Here's an equation for y. 20 minus 10 is 10, so y was 10. And I've now answered all the questions that they were asking. Boom! That was hard. I don't like that question. I'm not going to lie. I really don't like it. It's too abstract. Right, like I like the potato cannon one because it's a situation I can imagine. This is just too nebulous, right? It's two numbers. It is a question that does pop up on our tests. It's been like on at least half the tests in the last 2 or 3 years in grade 11 pre-calc. So study it up. There's a couple in the practice homework. There's a your turn. I'm not going to do it, but I could give you the answer if I did it. Yes, I did. So, if you just call your numbers x and y, I got 9 and negative 9, it looks like. And it asks you for the product, and the product is negative 81. So you can try it again. Very similar setup. There's your solutions. If you're having trouble, email me or come talk to me. I know, nobody likes talking to me, but you know I am here for you. So, this is actually my favorite kind of problem, and it also happens to be the hardest one, so that sucks. But, whatever. Just gonna check how much time. We've been rolling for 90 minutes. This is good. I'd like to be done by 25 minutes. So, the last one is the question type 4, modeling problems that have an increase or decrease. So I said for questions like this, we'll learn a neat way to set up the quadratic equation using 2 sets of brackets, one which increases, one which decreases. So I call it an increase-decrease type question. So it says, a student parking pass costs $20. At this price, 150 students will purchase passes. Somebody did some research. For every $5 increase in price, 20 fewer students will purchase passes. So there's lots of questions I can ask based on this, but in this one I'm saying, what price of the parking pass will maximize the revenue? So right away, I know that I'm looking for the vertex, and specifically the y value. Oh, actually no, it says what price, so that'll be the x value. And we'll talk about that later. We're looking for the vertex. And what is the maximum revenue? Perfect. Okay, so how do you set this up? Well, the first thing you need to answer is, well, how do you find your revenue in this situation, right? Like, you got these parking passes and you got people buying them. So I think most people would agree with me saying, well, the revenue is kind of like the number of passes sold, right? So whatever that number is, notice I put in brackets, times the number of, I guess, students in this case who buy a pass. That would be the revenue. Seems pretty solid to me. So when I'm talking about setting it up with two brackets, one that increases, one which decreases, I'm talking about this. And now you need to start saying, well, okay, let's call that R. And I'm being lazy. I should say let R be the revenue. Let R be the revenue. What else? Well, let's see what we get. So the number of passes sold. So go back to the question. What kind of information do we have there for the number of passes sold? Well, we have the price is $20, 150 students will purchase. Right, well, number of passes sold starts with $150. Okay, what's the price? Well, the price is $20. So at $20, 150 people are going to buy the pass. Now, here's the tricky part. For every $5 increase in price, so every time I add $5, now, this is the tricky part. X is my variable, so this is the number of increases. Okay, so I need to say, let X be the number of increases. So let's see if this makes sense. Every time I add $5, so if I go X is 1, that's 1 increase, I lose 20 students. So from the 150, I subtract 20 times the number of increases. Aha! So one bracket that increases, one bracket that decreases. Everything in this bracket has to do with the number of passes. So it was the starting number, and then the subtract 20 for every increase. Everything in this bracket has to do with the number of students. Actually, this is the price. Number of passes sold, number of students who buy. Yeah, so it's that or the price. Right, so $20 was the price, and every time I add $5, so every time I do one increment, I lose 20. So there you have it. Whee! So I would kind of summarize and say, this is my price bracket. This is my, I guess, number of passes. That's important because I can ask you anything. Like I can say, like, what is the price that generates the maximum? How many people will buy it? What is the maximum revenue? There's so many questions I can ask you. So if you set it up like this, you're going to be a happy camper. Now, what is this? It's a quadratic, right? I can see that at some point I'm going to get an x times x, I'm going to get an x squared, and it's going to be opening down, right? Because it's negative 20x times there. So I have some kind of parabola that's opening down like this. So I have a maximum right here. The max is going to be x, comma, the revenue. So this is going to be the number of increments, and this is going to be how much money I'm going to make. So they are asking us for the actual price, so we need to figure out x. So in other words, we need to know the vertex so that we can find x. Now, I'm not going to complete the squared because I have this in factored form, and I can get the x value of the vertex by finding the x-intercepts and then using my formula, right? So let's go ahead and find those x-intercepts. So we'll take the first bracket. We'll set it equal to 0. We'll take the second bracket. We'll set it equal to 0. This bracket, we're going to get 20x equals 150. So there it is. What is that, 7.5? Okay, 150 divided by 20, I think is 7.5. Over here, we're going to get negative 5x equals 20, so I just move that over there. And then I'm going to divide both sides by negative 5, so I'm going to get negative 4. Now, those are my x-intercepts. So now I know, okay, that's negative 4. This one here is 7.5. I need to find the vertex which lies in between. So, use the formula from the other day, where the x value of the vertex is x1 plus x2 divided by 2. We're going to pop in our numbers. Yay! I believe those were our two numbers. Let's quickly double check. It was negative 4 and 7.5. Yep. So the x value of the vertex, we're going to get 3.5 divided by 2. And I'll quickly check, is that 1.75? So that's the x value of the vertex. That is how many increases we're going to need to get our maximum revenue. So, go back to the question. What were they asking? They're saying, what is the price? Here's our price bracket, 20 plus 5x. So go grab that equation, say that's the price, and pop in what you found. Oh, great. And what do we get? I have to check my notes. Holy moly, my notes are huge. Where's the price? Aha! 28.75. I sure hope that drill doesn't come through on the video, but I guarantee it will. Good thing we're just about done. There's the price. These guys ain't letting up, eh? Were they asking anything else? So we found the price right. What is the maximum revenue? So we know the x value, and we can find the y value of the vertex by popping that in to our original equation. So you're going to go plug it in here and figure out what you get. So maybe I can switch colors really fast. So for every x here, you're popping in 1.75. Maybe pause the video for a second and try it out, but the maximum revenue that you're going to get after doing that, I have that in here somewhere. Here it is, $3,306.25. Boom! That was really hard. But we're done now. So make sure you try out the homework. Email me if you have questions. There's a your turn. It's the same question with different numbers. I'll give you that too. We're not going to do it. You can just refer back to my first example. But I'll give you all the important numbers here for this one. So if you want to pause it and then check back in a second, I'll give you this. So this is the equation that you're going to end up setting up. This one has a decimal in it, so maybe that'll be a little bit different for you guys. And then what do we get? They're looking for the price. So when I did this one, I wrote that. And then they ask for the revenue again. So it's exactly the same question at different numbers. It would be good to try it. And then when you've done that, we'll try exercise 28 and the chapter review. We're done the chapter. Bye-bye.